Hello everyone, today we're going to be looking at tectonic plates, which you might be familiar with from our previous work on earthquakes. Tectonic plates are very important because they cause earthquakes, but they also tell us about the history of our Earth. So today what we're going to do is we're going to use that knowledge to understand how the continents of the world have changed over time because of the tectonic plates. We're going to know that the surface is made up of tectonic plates and that they move very slowly over millions of years and cause changes in the land masses, things like mountains, earthquakes, and also valleys, and sometimes chasms like the Marianas Trench. So first things first, pause the video, see if you can remember the name of all the continents. Of course, I'd like to start with the Americas. You get North America up here, South America. Of course, we looked at North America, mostly at the United States, but there is also the bits of Central America, which count as North America. Africa, Europe, Asia, and Australasia, sometimes called Oceania. Now, the tectonic plates, they're kind of related to the continents because the continents are very often split up by them. It's because the Earth's surface is called a crust and it's made up of different rocky sections, which are called the tectonic plates. And you can see here on the map where the plates are, they can move about on top of this softer mantle underneath them, which is kind of like lava that the Earth is floating on. If we could slide South America towards Africa, do you think the two landmasses would fit together like a jigsaw puzzle? Sorry, I should say, do you see how this bit kind of fits in here? It's quite interesting. Now, this comes from an idea called continental drift, which wasn't always thought of. In 1910, a German scientist called Alfred Wegener, who's the first person to study the idea that they could have been a single landmass. But it wasn't until long after he died that he was right. Often in science, it takes a while before your ideas are accepted, especially if they're very different from what came before. The oceans the continents and the ocean floor beneath them really do float on the moving rock, and they have been drifting, but very, very slowly for millions of years. Wegener came up with some convincing evidence to support his ideas by looking at where the different fossils were and being able to piece the continents back together into one landmass from the time, millions of years ago, when the fossils existed. So you can see here in the diagram, a bit difficult to read the black on blue, that even in South America, there were these evidence of the reptiles here, the freshwater reptiles. Even here in Antarctica, there are some fossils of plants that lived a long time ago. Now, 250 million years ago, in what we call the Permian period, all the land on Earth was one large landmass. Wegener called this landmass Pangaea, or Pangaea. Over time, and this was about 200 million years ago, so even this difference was only after 50 million years, the moving plates started to split apart, and they cause two large places, one called Laurasia, which you should recognize as like Europe and Asia, and Gondwanaland, which is a mixture of the Americas and Africa. About 14.5 million years ago, so another 50 million years ago, the Jurassic period started. You might remember from Jurassic Park, and that was when the continents we know today, they were starting to become visible. If you look at the map here, you might be able to recognize some of the continents as they now are. Here in the Cretaceous period, 65 million years ago, think about it, can you spot some of these land masses and match them up to the continents that we have today? And then finally we get to the present day, over 250 million years later, where the movement of plates has created the land masses that we recognise today. Now the plates are still moving, but not by very much. They move by about between 1 and 10 centimetres every year. If you think about it, that means it could take between a decade and a century to even move a metre. They can move towards each other, away from each other, or rub alongside each other, which causes some of the earthquakes you looked at last week. Here's the Cliff Notes version. South America is slowly moving towards North America. North America is moving away from Europe and therefore towards Asia. And Australasia is moving in towards Asia. Could you imagine what it would look like in the future if these things kept moving? Here's going to be your task. You should be able to get into Twinkle Go. I'm going to upload one task to Purple Mesh as well. I'd like you to look at these and try as many as you can. If there are 3 options, 1 star, 2 star and 3 star, 1 star is the easiest, 2 star is about what I expect, and 3 star is a little bit harder if you fancy a challenge. Good luck and let me know how you get on.